Hey, welcome to episode number 146, where we are going to talk through a little bit of we're going to talk through the Cilium 116 release. We have some awesome contributors to the Cilium 116 release joining us. But first, as usual, we're going to go ahead and go through some news stuff, and then we'll get into the good stuff and meet our contributors and all of that. First things first, coming right up, at the end of this month, there is a 2-session getting started with network security, intro to networking security and SecOps. We're going to start on July 30th, and we'll have a follow-up session on August 2nd. If you haven't already signed up for that, make sure you get signed up for that. There's a link in our notes. And as usual, you can get to our notes by going to the hackmd.io/@ECHO Live right here on the bottom right-hand corner of the video. You'll be able to see that link. You can go there directly. And I can also share the link in the chat like usual. So we can copy that and I'll put that into the chat. So if you're listening and you want to be a part of that training, then you can go ahead and just click that link, and the link it'll link you out directly from there. We also have the eBPF Summit coming up, which will be again, it will be virtual. So if you want to come and check that out, definitely sign up, register for it. It's a free conference. It's in its 5th year. There's lots of great folks presenting on all things eBPF, not just like Cilium or Tetragon or any of the things that you see me talking about on this show, but also like all of the interesting, crazy stuff that people are doing with eBPF in their daily life, which may be totally unrelated to like what we're doing with Cilium and all of that stuff. So that's pretty exciting. I love the just the breadth that people are doing with eBPF, like all the amazing stuff. What else is in our news category today? Of course, as usual, if you would like to see this show up in your inbox, you can do this. You can actually sign up for this year. But this is obviously the weekly news that Bill puts out. Lots of great stuff in there. One of the things that caught my eye this time was that somebody has actually taken the time to build out a Tetragon playground. So ready to play examples in Docker Compose. There was also, I can't remember where I saw this, but I kind of like this one, although the title is a little risky. Learn to drop outgoing packet for targeted processes using eBPF TC filters. Writing eBPF trace points with Rust. And then in the ecosystem, we have BPF Conf 2024. Again, just a bunch of folks talking about like what they're doing with eBPF. Pretty exciting stuff. A really exciting part of our 116 release. Now, understand that like while we're excited about it, this is still very, very cutting edge stuff, right? Like NetKit is like, I think in the newest kernel or something like that. It hasn't been around a long time. It hasn't been tried and true. It probably is not going to be part of the enterprise version of 116. Because it is so cutting edge. But at the same time, like what we can do with it is amazing. And so if you're curious about hearing more or reading more about how all of that works, definitely check out the blog on that. We have a couple people joining us from the audience. Hello, no username. And hello, Gonna Talk. Welcome, welcome. If you're out there and you'd like to say hello, definitely do so. Other things in the news one, I did see that somebody had actually, on the how-to side, somebody had taken the labs that we build around BGP and figured out how to actually run all of that stuff locally with Container Lab. And I thought that was a pretty awesome piece of work there. So Ariel has actually done a bunch of work on reproducing some of the labs that we've been hosting on BGP locally and has its own GitHub repository with its own makefile, kind of showing how all of that works. So pretty neat stuff. And then the video, lots of great stuff coming. The Nico has just put up a video that's talking about Cilium Gateway API and Gamma. Gamma stands for Gateway API for services that are like within your cluster. I can't remember what the actual breakdown of that term is, but fundamentally, like Gateway API gives you things like header routing, percentage-based routing, a lot of the more complex use cases for layer 7 ingress and that sort of stuff. And Gamma takes a lot of those same use cases and applies it to not just north-south traffic, but also east-west traffic. So actually, how do you access services within the cluster? Do you want to send some percentage of traffic to a new version of a service, etc., inside the cluster instead of just from just north-south, which is pretty exciting stuff. Again, super early work, but it's exciting to see where it's going. There is this port range support made the newsletter. I like that. BGP support for cluster IP. Interesting. Yeah, lots of great stuff. So let's introduce our guests. We have Mr. Rob Scott from Google.
Hey.
Oh, I just realized I'm blocking you with show notes. Let me turn that off. Boop, there we go.
Yeah, hey, I'm Rob. I work at Google on Kubernetes networking things and also do a lot of things on Gateway API and OSS. So always very excited to see Cilium doing more things with Gateway.
Nice. Do you work with Ben and those guys as part of that?
Yes.
Nice.
Yes, we actually work in the same building. Well, when we're actually in the office, which clearly not now.
Yeah. And we have Nathan Sweet, one of probably the most OG maintainers in the Cilium OSS project. Like you started like way back, right? Like
kind of. I started 4 years ago full time, but I was the creator of the Cilium eBPF library. So that, I think sometimes people add years onto my tenure that I don't necessarily deserve, but
yeah. But also, like working in startup life, I think it's like it ages you in dog years.
That's
like,
true.
So
yeah, 4 years.
4 years is really like 20 years.
It's like 10. Yeah.
And we have Mr. Chance. Chance and I work together at a few different companies, but it's great to see you here at Isovalent as well. Welcome.
Thanks.
I think you're muted.
Appreciate it. Yeah, I pretty much just work on the Hubble subsystem, and it's been pretty fun getting to see all the new contributions and the kind of where Hubble's been going with the service mesh and all the other features that have been getting introduced to them. So pretty excited to be here.
And we have Tom Amani joining us from, I believe it is Microsoft.
Yeah, I work for Microsoft, so I lead networking data plane for containers in Azure. So I'm really excited to be here, and my collaboration with Cilium is for past 2 years, and mostly work on the network policy and FTD and stuff.
Nice, awesome. All right, let's get started with Mr. Rob Scott. We're going to talk through the contribution that you have made to Cilium 116. And then once we get through all of the contributions, we're actually going to do an overview of the Cilium 116 release. So stick through and go through the contributions from some of our awesome internal and external contributors to this particular release. So Rob, this is the contribution that you made. I actually saw you were a new contributor for this with this run, right?
Yeah, I mean, I've been in the Cilium ecosystem for a bit, but this is actually my first PR that has merged, first commit, all that stuff. So cool feature, but the actual Cilium implementation was fairly simple, so it felt like a fairly good starting point. But I'll say there's been a lot of confusing history, and anytime I talk about traffic distribution, I feel like some baseline slides are helpful to try and explain what on earth we're doing here, because it's been a journey. Let's say.
This is the third implementation, right? Or is it the fourth?
Yeah, and this is 3. So 3 strikes, you're out. Hopefully we got it this time. I don't know. We've been through a few. The first implementation that used topology aware routing, or that kind of concept, was so incredibly flexible. It was incredible, but it gave so much flexibility to users that, 1, it's confusing for the base case, and 2, it was very, very difficult to implement and test. So it never made it out of alpha, right? Because you want E2E tests, you want some form of reliability, you want, and trying to get other data planes to implement this, it was, the implementation was never actually what it promised. That's what I said. The API promised a really advanced thing, and then the implementation never caught up to the API. So that was unfortunate. And we said, what if we try something simpler? And I'll cover, basically V2 and V3 in these few slides because they're pretty similar. So I just want to talk about traffic distribution, which is the feature that we're adding support for, or have added support for, in Cilium 1.16, and then previous attempts at topology and how this all works with Cilium. So, if you look at the overall architecture, you've got the endpoint slice controller, which is basically merging together services and pods. And then distributing the endpoint slices are watched by Cilium. And those endpoint slices contain some kind of hints for how Cilium should route traffic for those services. So that's all well and good. But if you're familiar with Kubernetes, if you're familiar with Cilium, you know that by default, traffic is just spread everywhere pretty equally, right? It's trying to even out traffic and have every incoming connection have a same probability of going to any endpoint behind that service. So this is what I would call the safest approach. It's the least likely to overload traffic. It's pretty safe for auto scaling, all these great things. But of course, some cloud providers and charge when you're crossing, across zones. In this case, that's problematic. A lot of customers are trying to save costs, and some also just fundamentally want to have availability concerns where they want to have isolation across their zones. And this doesn't really help with either of those. So ideally what you'd want in this, scenario is that everything stays in the same zone. You have a request that originates in zone B, it should go to pods in zone B. And I've had so many people say, well, that sounds so simple. And yes, it should be so simple, but the long tail of problems with this is non-trivial, and we have struggled with this for a while. But what we started with was let's aim towards this and see how close we can get, and have some reasonable fallbacks if we can. Now, if you've been following Kubernetes and if you've been following Cilium, you may know that Cilium already supported a feature that was called topology-aware hints. That's what I would call the precursor to what we're now calling traffic distribution. And let me first say that Kubernetes, myself, anyone, just not good at naming things. I apologize on behalf of the community. Now, topology-aware hints was this idea of, this is dangerous. Let's try and make it a little bit safer for you, basically. So if you have, one of the things that we just expected is that you're not always going to have universal, evenly distributed pods across all zones. Like if you have 3 zones, you're not guaranteed to have the same number of pods in each zone. So an idea was, what if we try and even that out for you? We'll try and, keep traffic in the same zone as much as we can, but we'll try to take, if we think zone A has more endpoints than it needs, we'll try and take one of those endpoints and give it to zone C if we think it doesn't have enough. So this is really trying to even out where we're routing traffic and make it what we thought was reasonably safe. And although this seemed sensible at the time, traffic distribution is what most people actually wanted. So the idea that the difference here is topology-aware hints is trying to even out, where your pods, make sure that every zone has enough endpoints for you. Whereas traffic distribution just says, you can figure out how you're going to schedule your workloads, and we'll just keep all traffic in zone if there's a single ready endpoint in that zone. That's the main difference. Yeah, and so hopefully that distinction makes sense. It may seem like a bit of a, maybe downgrade or upgrade depending on your perspective, but we think it's much, much simpler to understand. One of the things that we got feedback for on this in particular was that it was very confusing. And let me just, I'm going to gloss over just how confusing it was, but anyone curious, we had all this complex stuff about like an overload percentage, an overload threshold, some proportional allocation. I'm not going to get into all those details. There's just a lot here. But basically, there was a lot of calculation of when do you want to take an endpoint from zone A and send it over to zone B. And it got very, very, very confusing. And there were some times where we thought, well, we just can't possibly evenly distribute endpoints enough, so we're not going to set hints at all, and we're just going to spray traffic. And that was actually technically safer, but it was wildly confusing to anybody who wanted this feature to work with a small number of endpoints. So for example, if you went from 3 endpoints to 4 endpoints in a 3-zone cluster, you'd lose hints, you'd lose same zone routing because we couldn't evenly distribute that. So that's how we, you know, in this world, we still saw, okay, 85%, almost 85% of traffic would stay in zone, but that's not really, that was overly confusing, overly complicated. So traffic distribution is what we settled on now. And that's just keep everything in the same zone. And this, I think, is much easier to reason about. And we've left a lot of flexibility in, because if you look at this and you say, well, a big part of our problem with this is that you don't really understand if an endpoint is overloaded. The idea of traffic distribution is you can improve if Cilium in the future, and I hope it does, has a better way to route than just always same endpoint, always same zone. This definition of traffic distribution prefer close gives implementations a lot of flexibility in how they do this. So if they believe there's a better approach and they have the capability to have a better approach, they definitely can. So yeah, go ahead.
I think this might tie in a little bit to the gamma stuff.
Yes.
Thinking about how this might work. Yeah.
You know, one of the things that we have to be thinking about with Kubernetes API is how it ties into the ecosystem, right? And so this is sufficiently open-ended that we believe this will work very nicely with Gateway, with Gamma, with other providers that most have a concept of I'd rather prefer close, like I basically value proximity over reliability. And so given that, how can I adjust my routing to meet that goal? But I do just, you know, in closing, want to call out one very big painful gotcha. So imagine for a second that all your traffic, all your incoming load is coming from zone B. That's just, you know, and what do you know? I've got 9 pods, 9 endpoints, and they're distributed across every zone because we've said all our traffic is going to stay inside zone B. Zone A and zone C endpoints can't help us out, right, in this naive implementation, right? So you have a very high likelihood that you would overload endpoints in zone B, and then maybe even worse than that, if you have, say, auto-scaling set up to handle this, auto-scaling might not pick this up either. So just think about this for a second. Let's say my load, 3 pods in zone B are at 100% utilization, but I've got 6 pods in other zones that are hardly utilized at all at 10%. So my average utilization is still pretty low, and so I'm not going to scale up. So this is a real gotcha you have to watch about. There's some information in Kubernetes docs about how you can avoid this, but just be very careful when you do traffic distribution that you understand where your traffic is coming from, and you might want to have an HPA per zone instead of per service or per deployment.
So this assumes that like the source is going to be something that you know is a part of a single zone. So like ingress in Cilium's case is actually spread across all zones. So you would still get a better dispersal because you're actually thinking of ingress as more of a global thing.
Yes, exactly. So this is really when you're talking about it, like cluster IP routing, where you might have a single source workload that's all in one. Maybe it's just one pod that's sending all your traffic. I don't know, right? And they just happen to be unlucky and they're all in one zone. Yeah,
makes sense.
And so I'd say traffic distribution is exciting. There are those gotchas, but it's beta in Kubernetes 131. That means it's available by default, and it's supported in Cilium 116 and beyond. So hopefully this is good news. I'm looking forward to feedback on this. And I also just want to call out the vision. We're not stopping here. One of the things that I'm really excited about Cilium in particular is we're exploring adding a feedback loop. We've been so lacking in Kubernetes in terms of making routing decisions based on if an endpoint is overloaded. But we're exploring the idea of adding XDS. That's just a protocol that is associated with Envoy and gRPC to Cilium. But the key reason for that is it adds load reporting. So you can understand that I am, if an endpoint is already at capacity, maybe I should spill over to another zone. So basically to address some of those gotchas. So lots of work in progress, but excited about traffic distribution, and yeah, happy to talk anymore.
How would you say the contribution process went for you? Like, I know this was one of your first contributions, but you've been a part of the, kind of been in a project adjacent for quite a while. Like, did you feel like you had the support you needed to get this in? Like, how was that whole process?
No, it was great. I appreciate everyone who helped along the way. This was a fairly small change, but I have been working on some bigger ones like that XDS support. I just want to say the Cilium community has been very welcoming and reasonable. The XDS bit that I'm exploring right now is a fairly big, long-reaching project, and I've gotten a lot of collaboration from contributors at different companies, lots from Isovalent, Microsoft, etc. So it's great to see open source thriving in this community.
That's awesome. Well, thank you very much. And thank you for, I'm glad that you're now a contributor, an official contributor. I'm looking forward to seeing where all the rest are.
Yeah.
Mr. Nathan, next up is port ranges and Cilium network policy. That has been such a long time coming.
Yeah, I think 3 years. I don't think that's how long we've been working on it, luckily. But yeah. Yeah, I think port ranges started out as an issue in 2021. And I believe Joe Stringer came up with sort of a naive back of the napkin solution involving adding every single port into the map. So a little bit of context, the way policy enforcement works in Cilium is that we convert Cilium network policies into sort of selector policies that are endpoint agnostic. And then when it comes time to populate the BPF map state, which is what ultimately does the enforcement on the data plane, those sort of selector based policies are converted into identity based policies. And identity is Cilium's concept for like what the actual endpoints are in the data path. Policy keys are port, protocol, and identity, and a couple of other things. And so that idea basically means that if you had a port range of like, say 65,000 ports, which, hopefully that's not something you're doing, but if you did, that would mean 65,000 key entries into the BPF map, which is obviously not scalable. So we searched a lot of, I need to shout out 2 other engineers who helped a lot on this issue. Jarno Rajahalm did most of the data path work, which actually ended up not being most of the work. Most of the work was in user space. And then Casey Calandrello, who did a lot of review in the user space work. But what we've discovered when we were trying to implement this is that we needed to have a user space library or user space data structure that mimicked the BPF data structure that does the enforcement. So the BPF data structure that does the enforcement is a map structure called longest prefix match. And what it does is it takes key entries, and you can specify a prefix. So I'll just share my screen quick.
Okay.
And do a little demo here. Okay. So this is kind of what port ranges look like. Or we'll just deal with a simple idea of ranging an unsigned 8-bit integer. So if we want to create a range of 1 through 7, and divide it up into longest prefix match keys, then we actually have to create three separate keys. We create a key of 1 for 1, and then it has a full prefix of every bit has to be what we specified in the key. That's what all these ones represent, is that none of these keys or none of these key bits can be different. 2 through 3 has a wildcard at the end. So we can have this last bit be 1 or 0 based on the prefix. And then this prefix, 4 through 7, the last 2 bits can be 0, 0, 1, 0, 1, 1, or 0, 1. And that effectively creates a data structure that allows you to look up if a port matches this key, right? So we can check if 5 matches this key and prefix. And so Golang actually didn't have a bitwise longest prefix match library. So that's something we had to create for this feature, which is, you can see it linked in the issue. This is the PR that created that new data structure. We did look into using byte. There's a lot of byte-oriented longest prefix match libraries in the Go community. And we looked into using them. But the problem with that is that for, say, just one port range, which is a unsigned 16-bit integer, that would mean that there would have to be 16 bytes per key. And sometimes we can have thousands of these things, and so it doesn't necessarily scale well, and even tens of thousands. So that didn't really scale well, given that it's almost an order of magnitude difference. So we created this LPM tree in user space that basically mimics exactly what the Linux eBPF map does. And then that allowed us in user space to, one of the things we have to do with policy insertion is that as policies come together in Cilium and match a certain endpoint or match certain egress or ingress traffic, is we have to deconflict those policies. Sometimes those policies don't play nice with one another. And so you have to do a lot of precedence checking, right? Like an allow is overridden by a deny, a redirect overrides an allow, a wider port protocol allow should allow this traffic, but you might have like a deny hole within that allow that you have to also enforce. So there's a lot of precedence and hierarchy that needs to be enforced. So by creating this user space library, we were able to eliminate a lot of precedence logic outside of just the port range feature itself. And so it kind of was 2 birds with 1 stone. It allowed us to enable port range policy maps because as we process the policies in user space, we want to flatly insert them into the BPF map so that when the data path is going, it just does a really simple, it's basically an O constant time lookup. Insertion is not constant time. It's the thing that's costly. And so that's all worked out in user space. And so, yeah, that in a nutshell is a lot of the work. And then, these separate PRs sort of reworked the policy engine to use this new data structure rather than we were using a built-in map type in Go before. Yeah, I'm trying to...
Previously insertion would mean that you would have to actually evaluate the whole set again. And now with this new LPM, it's a lot more atomic.
Exactly. Every time we inserted a new policy in user space, we would have to check it against every single policy that we knew of that had the same overlapping selectors. Using this new data structure has eliminated that, and now we smartly traverse the trie, which is what this is. It's a longest prefix match trie, and that allows us to eliminate an enormous amount of traversal. And this won't be coming out in 1.16, but Yarno used this work to create a ton of optimizations. I think I have his work somewhere around here. Yes, this do not scan all entries when adding new ones work. Basically, he has a benchmark here where he tries to insert 117,000 entries into the user space map state, and with a lot of CIDR, with a lot of complicating CIDR deny overlap, and that took 763 seconds to do. And then with his changes, it took 3 seconds. So he was able to get like an 1800x speed up on top of this work. So in addition to port ranges being supported, it also enabled an enormous amount of speed up, especially around deny insertion.
Because previously, so in the previous case before the trie library, you would do a thing where, like, every one of those rules, it becomes like an n squared problem, right? Because like every rule adds a new rule, adds a new policy. You have to evaluate all that existing stuff, add a new rule, evaluate all the rest of it's like continuing to grow out of bounds until you get like wild.
And we had lots of like hacks to get around it. But one of the ultimately where all of our hacks led us is to making deny insertion really slow for people. And we've pretty much solved that now in 1.17, which is really nice. Yeah. I'm trying to think of anything else. So yeah, just a little bit about how the keys break down. So you can imagine inserting 1 through 7. That actually does create 3 keys, right, in the data path. Mm-hmm. So when you're creating these policies, I think the worst case scenario is that one policy could potentially create 30 entries in the map. But it's not determined by the size of the range. It's actually determined by how we can refactor your range into different powers of 2, because that's how the bitwise LPM works, is that everything needs, obviously it's bit logic, so it's powers of 2. So it's not appropriate to think of these as masks. They're prefixes. A mask is something where you can have ones after zeros. You can't do that in longest prefix match. You can't have dynamic masks where the least significant bits are masked, but maybe some most significant bits aren't. It has to go from most significant to least significant.
Yeah.
And so that's why you have to divide the ranges up into more than one entry.
So in practice, it's longest prefix match, but it doesn't mean it's the only prefix match, right? So you would hit this one, and then you would hit another one, and that would identify which of the 2 you were.
Yes. So this covers the full range these entries do, right?
Yeah.
So this is a single entry covering 1 port, and then that divides it into 2 to 7. But that's still not 2 to 7 is not a power of 2, and so that needs to be divided further. Yeah.
What has you excited about the Cilium project? I mean, obviously, it's like this is a huge improvement, but is there other stuff outside of this that is something that is on the roadmap or that you're working on that has you interested?
Yeah, network policy doesn't seem like this very cool area, but actually there's a lot going on in it right now. The upstream community, or the Kubernetes community, is pushing for admin network policies. There's a lot of new APIs coming online. And especially as cluster sizes go up, it's becoming a lot of the issues around policy management are around how to scale policy, not just policy engines, speed and performance, but also just management itself, because there are there are users out there of Cilium who have tens of thousands of policies, and so it's not really feasible for an individual to necessarily have their brain wrapped around every policy that their cluster is enforcing. And so trying to solve that person's problems is I think an interesting and fun thing to do.
Very cool. Well, thank you very much. Mr. Chance, you are next, and we're going to be talking about the CEL filter support. And I have a couple of browser tabs here. Kind of.
Yeah, I also have some stuff to share. Yeah, I mean, so this is new in Cilium 116. It's something that I even evaluated for 115. It's been something I had prototypes for quite a while, but was kind of figuring out whether or not this made sense. And a few things aligned to make this kind of an obvious choice. Well, first, like before getting into like what it means in the context of Cilium, it probably would help to explain what CEL is. So like CEL is the common expression language, and it's I believe it's a Google project, and it was created to kind of make it possible to do filtering or like predicate logic in various other projects in a fast and safe way. Embedding DSLs is always a challenge in projects. It's a performance problem, it's a security problem, it's a complexity problem. Most DSLs are typically either kind of difficult to use because there's some other language like JavaScript or Python being embedded into your other system, which is probably like in Kubernetes. And Cilium's case is it's a bunch of YAML, right? And writing JavaScript and Python or whatever in YAML is challenging. But CEL basically lets you do really cool things. So you can do predicates being like true or false answers to an expression. And you can do it over structured data, which is really important because at least in the Kubernetes and Cilium space, there's a lot of objects, right, with nested fields. They have arrays, and it has typing, which is really great because a lot of the time DSLs tend to be kind of this like more dictionary object oriented, where you're just kind of dealing with unstructured data, kind of like in the same way like you might use grep or sed. It's kind of like you hope that it's well formed and you hope that everything works out, but you might get an error later. And where this kind of aligned is that CEL has been making its way into the Kubernetes ecosystem, into CNCF projects. There's other projects that are using CEL as well. And so it's becoming adopted by other tools and projects in the ecosystem, which means that people are going to become more and more familiar with it. In Kubernetes, it's going to be one of the main ways that you can do complex validation of resources. So historically, it's been open API validation, where you can write these rules in a YAML JSON DSL, and it says, you can write, certain fields conflict with others, but it's pretty hard to do more complex validation. And an example of that is like validating the format of a string means regexes. With CEL, you could technically do it with some more logic. You probably will still do something with regexes to some degree, but you can definitely do more advanced logic. I like this one about like dates. I think that's like kind of a good one where you can kind of do these nice complex comparisons between two different fields. Like the created field or like a modified field should always be after like a created date field. Like it technically probably is possible in certain fields in Kubernetes, but today with CEL, you can make more advanced comparisons. And like I said, it has type checking. So it lets you, it will tell you when your expression is wrong, not just it will let you write something incorrect. It will actually kind of catch that at the parsing time. Cool. So in the context of Cilium, I introduced CEL to support advanced filtering in Hubble. And so Hubble, if for people who might not be familiar, is a good way to query observability data from Cilium. You can think of it as like flow logs, but for your Kubernetes cluster. You can find basically what is happening in the cluster from a network point of view, according to Cilium. It can tell you about policy denies. It can tell you about what traffic's being forwarded to what endpoints, and all sorts of useful things like that. And so historically, Hubble, we have this issue that has been open for a while, and I guess this can now be closed. But there's certain filters that or expressions you couldn't do. So like this example is like you might want to filter on where a flow is not from a remote node and not from a reserved host node. But they were actually really trying to do it more like an OR, I believe, in this case. So like you can do ORs with a given single field where like each namespace, you could say this namespace or this namespace or this namespace, but not this one and with this label. However, all those inclusion filters got combined separately from the negation filters. And that was basically where the problem lies, is you can't actually do these complex
filtering after, yeah.
Yeah, you can't kind of combine, like the more, you can't have like parentheses and an and in between anything. It doesn't work that way. And so that was kind of the main motivation for self support, is to give an escape hatch where existing filters didn't give you what you needed. And so there's some examples of what it looks like. And I think it's still possible we might adapt it a little bit to make it more friendly. But this is kind of a bare bones implementation. Don't read this diff. It's actually a much shorter implementation. That's all vendoring. It's probably like 50 lines of code to actually implement this into Cilium, which was great because Cell is all based on the protobuf types that we have, and it auto generates everything kind of in its interpreter from the protobuf types. And so there's some considerations with Cell, like it's not going to be as performant as the kind of native filters. So you might prefer to do like kind of your baseline filtering and your normal like Hubble -- namespace filter, and then everything else that's more complicated in Cell. And that way you kind of get the best of both worlds, because you can use both. Cell expressions are just another filter. They don't replace existing filters, and it can be used in both include and exclude. So I have a little demo to kind of show you what this looks like. So let me change the presentation really quick. The main thing with Cell is that it does take a bit of wrangling to get your expressions to do what you want, because it is strongly typed, or it's gradually typed, but it is still strongly typed. So, but before I get into that, here's kind of what I have for my demo. I have a kind cluster running Cilium 116, and in my top two panes here, I have just kind of some terminal windows running in this Alpine container in the default namespace. And so this is just going to be used to generate some traffic. So I have one loop that's going to talk to this 1.1.1 using HTTP, which will be port 80. And then in this other one, I have a dig command running, which will query 888 for DNS, and it will try to resolve Cilium.io. And that gives me, port 80 traffic, HTTP, TCP traffic on the top. And then I have port 53 DNS UDP traffic on the bottom. Just two kinds of different, basically, traffic types. And so this is the example I used in, well, first, let me just show you what Hubble looks like. So I'll just run Hubble observe, and you can see that we get flows. That's the main thing Hubble is for, is it provides you a bunch of information about the network traffic happening inside your cluster. You can see Hubble is talking to Cilium. You can also see, maybe not actually quite here, you can see my Alpine container is talking to 1.1.1 on port 43 and port 80, because it's doing the HTTP redirect to HTTPS. And then you can also see that it's talking to kubedns or core DNS inside the cluster to resolve DNS entries. And so what I'll do is I will do my cell expression. In fact, this is it right here. And so this is kind of the example from the pull request. I know it's kind of probably a little hard to see. Let me see if I can.
You can see it okay.
I'm filtering for where the destination, the source traffic's in kube system, or the source traffic's in default and targeting kube system. So for example, if Alpine container is querying traffic to kubedns, this should show up, but also any traffic in kube system should show up. And this is an example of something that was previously not possible because you couldn't do this nested conditional with on the right hand side. So I do that, and voila, we see Alpine container talking to core DNS, and then we also see other traffic going on in that's just coming from kube system. So like Hubble Relay is talking to Cilium. That's a great example. There's other things you can do. Just kind of to show you a bit of a better idea of what's possible. You can filter on all the same things as before. So you can filter on IP addresses, right? You can filter on the protocol. So in Cell, this will be a little more different because you're basically checking for the presence of certain fields existing. So if this was a UDP flow, you wouldn't see the TCP field would not be set at all. So we use the has function that Cell provides. You can also do that obviously for UDP. We'll see our DNS traffic. And then a more complicated one that will filter for everything that we've got going on here is going to be like this, which you can check if it's TCP and the destination is 1.1.1, which will be my top tab, or I can check if it's UDP and the destination is 8.8.8 and the port is 53, which there you go. So, well, I guess it's actually going to be going to kubedns, so the second filter didn't match. But in any case, this is kind of what's possible with Cell. You can do these more complex expressions. I can still use all my regular filters. So I can add kube system to here, and I probably have to remove one of my other filters, but everything's compatible. And it really kind of lets you do any kind of thing that you need with Cell or with Hubble when it comes to filtering. And this doesn't just apply to the Hubble CLI. You can use this in the file export. So you can pick basically like what flows you want to export to disk, or Steam export, for example, among other things. So there's a lot of places Hubble filters get used. It's not just the API, which is kind of why this is great that it's part of a flow filter piece of Hubble.
And to understand like the fields that you would want to apply, like if you're doing IP destination or things like this, you can look at like the JSON output and see like what the actual breakdown of a flow might be, right? Like
yeah, exactly.
Anything in there is available to you?
Yep, pretty much. And the Cell basically uses the protobuf types. So there is some documentation in terms of like how you look at a protobuf message and like think of it in terms of Cell. We are working through like how we want to document this, because right now we still actually lack a little bit on just the regular Hubble filter docs. We have getting started guides on how to use Hubble itself, but we don't have details on like, here's every possible option with the Hubble CLI. And so we're still figuring out where to structure that, and we don't want to like make users think Cell is the only option. But yeah, you can basically kind of just underscore flow dot the field that you see in the JSON from the protobuf. So hopefully that makes it a little easier.
What is something else that you're working on as part of the Cilium OSS project that had you excited?
Well, I think one of the like more interesting things going on with Hubble right now is we have a little bit of work going on in metrics. We have some have a contributor who has kind of proposed like a new way to reduce metrics cardinality, and one of the big requirements for that from the Hubble contributor side is that right now the way you configure metrics is somewhat complicated. The configuration of like what labels you want, it's all kind of in one string, and that's challenging for a lot of reasons. It's complicated for the code to handle, and so we're kind of looking to introduce maybe a new config file to configure your metrics, and that config file will give you a lot more the normal like structure that you can get out of like YAML or JSON, right? And I think that's really exciting because it will let you do things like I want my flow metrics, and maybe they have pod names in them, and that that could easily blow up your cardinality in metrics, which means you get way too many metrics. It costs more money to store. It costs a lot of storage and time to query. So one option is to then filter which namespaces or which pods these metrics get accounted for. So you might have really busy pods, maybe like your DNS pods, or pods that are really heavy in churning that you could filter out. And that way they don't contribute to your metrics, which, that is its own downside, but it also might just let you filter out the things that you don't care about and get the counts that for what you really need, while still saving on costs. So it's just kind of more flexibility to the options you already have.
Nice. How dynamic will that be, out of curiosity? Like is that configuration file has to be there at boot, or is it something that can be configured over time?
I think in the initial proposal, we were thinking it would just kind of be mounted as a config map, and config maps, as long as you can change it, it will get reloaded on disk. And I think because we have a similar system already for the file export, the idea was we would just use the same underlying libraries for that, which does support a basic file reload. It's might as well just make it reload the file. I think it's every few seconds it'll reload the file, or uses iNotify. And one of the cool things with that I envisioned, at least, is for vendors and for operator authors looking to automate more things, is you could create that config map out of band and generate it. And you could have an operator, or you could have maybe your cloud control plane, whatever it might be the front end for configuring these. Like you might build a web UI, click a button, and it enables TCP metrics, as opposed to having admin access only. You have to run Helm upgrade or Cilium install. Having it possible to specify an external config map lets you kind of manage it out of band. And that's pretty great, I think.
Yeah, I was thinking, because to your point, it's metrics are generally a known problem, right? Where you know what you want to measure and you want to measure that thing. And then you come across a known unknown and you're like, actually, be great to have some metrics on this one, right? Right. Yeah, now I have another known problem that I want to add to the stack, or maybe just for a period of time while I'm trying to understand the state or what's actually happening with this particular pattern that I'm seeing, right?
Yeah, it's funny you say that, because they originally the contributor had proposed making it annotation based, which is something we've done for certain resources. Like you could annotate previously, or I think it was label, I can't remember, for L7 visibility, and it would kind of behind the scenes generate a network policy almost internally, but we removed that. And I think that was a good choice, because it kind of is one of those all of a sudden non-admins can do things that could potentially be problematic. And so we kind of shied them away from that. But what's great about the network or the metrics config option is, because our flows have pod labels, right? And in theory, we could add annotations in theory. You technically could write a config file that selects for pods with a certain label. And it would catch or filter for for pods that have that label, so that metrics are only applied to those pods. So you could still actually achieve exactly what they wanted from the beginning through this slightly more flexible system. And so I think that's kind of something we're trying to maybe do more of, is build these more sophisticated base layers that admins control, and then enable them to give their end users the capabilities to doing these things in a more controlled manner. And that way they can kind of pick the labels, that way they can control these things, and it's not some feature that they have to know exists and is documented to lock it down with some validation policy engine somewhere. They can kind of this is the label, it's company.org/Hubble metrics enabled, and they can write policies to kind of make sure that only certain people can do that if they want.
That's super cool. Well, thank you for the contribution, as always, and I'm looking forward to seeing people use this guy.
Yeah.
Tom Amani, welcome. We're going to talk about yours. This is speaking of iNotify and being able to dynamically change things, this is an interesting one too.
Yeah, sure. So I don't have fancy slides for my the people who talked before, but this is a relatively simple feature compared to the features we talked about. So I can guarantee I can explain about this feature in the words. So before even we dive into this disk-based policy, I want to give an history of context, like how we ended up in creating this feature, and what is the why we need this feature at all, right? So as a cloud provider, we wanted to like block access to certain endpoints, infrastructure endpoints, which we don't want pods to access to. Traditionally, how do we do this? We create an IP table rules, and then we say like block the access from pods to certain endpoints in the infrastructure. But with the advent of Cilium and eBPF, network policies and everything come implement via eBPF, and so we also naturally wanted to implement this infrastructure-based policies, right? So which we want to enforce through eBPF, and so that's where the idea came, like moving away from IP tables and then keep everything in one place, like implement all the policies via eBPF itself. So one option is to do is like create a cluster-wide Cilium network policy, and then say like I restrict access to this infrastructure endpoints from these pod selectors or pod labels for all pod labels. But then that's a problem of conflict between like so usually like the cluster admin is the one who manages the policies for the clusters. They then think themselves they manage all the network policies, but now there is a conflict, like cloud provider add a new Cilium cluster wide network policy, and then they say cluster admin cannot alter or update these cloud provider policies. So that's a conflict to be resolved there. So today there is no outback. We can say like, okay, these policies are managed by cloud providers, cluster admin cannot interfere, or these policies are managed by cluster admin, whereas cloud provider cannot interfere. So that's where this idea of disk-based policy born. So here the idea is to like the cloud provider manages the configurations for Cilium for managed Cilium offering that we do in AKS, and where the cluster admin cannot alter the Cilium configuration here. So with this policy, the user can configure the Cilium agent with a specific field, which is specified as static CNP path. It specifies the directory where the Cilium agent has to load the policies from. So we know like for all network policies, users create policies via CRDs. They define a network policy resource, CNP resource, and then define the policies. With the disk-based policies, so when you configure the Cilium with a specific directory path, the Cilium agent will start another controller which watches on that specific directory, and then it reads all the network policy YAMLs from the directory and then convert to a Cilium network policy object, and which eventually translates to rules and then gets added to the policy engine. So in that way, so these network policy resources will not show up as a resource when you do kubectl get network policy, or when you do kubectl get Cilium network policy. It will not show up a resource, but still the policy will be enforced in the cluster. So the cluster admin thinks like he's still managing the network policy resources in the cluster, but it is a win-win situation for both cloud provider and cluster admin. Cloud provider able to enforce the policy that he wants by default across all the nodes in the cluster by blocking the access to the infrastructure endpoints, and cluster admin still thinks like he manages the network policy resources for the things he wants. So additionally, this directory policy watcher also it's dynamic, like it watches on the directory, it keeps tracks of what are the files that are getting added in the directory, and then or getting updated, or if anything getting removed from the directory, it does add rules to the, I mean, it updates the policy engine accordingly. It either like add the rules to the engine on addition of new policy, or if the file gets removed, it also removes the rules from the policy engine. In that way, it is similar to how you create network policy resource and delete network policy resource. So creating network policy resource is equivalent to creating a file in the directory, and then if you delete a network policy, it's similar, like you can remove, when you remove a file from the directory, it's similar like you are deleting a network policy resource. Yeah, so
got it. And so these would always take higher priority.
Yep.
Even if you were to create a network policy that would conflict with this, these would always be a higher priority. That's really cool.
This is similar to how you do. So the only difference is where the source of policy is coming from. Like it's either coming from CRD, like from the API server, or it's coming from a specific directory path. So that you can identify based on like Cilium has some debugging tools, Cilium endpoint get or Cilium policy get, and there is an attribute in the Cilium policy get when you in the results, like a source attribute. From the source attribute, you can determine if the policy is created from directory or the policy created from Kubernetes. But otherwise, like it's similar to whatever the network policy that Cilium supports with Cilium network policy or cluster-wide Cilium network policy that.
Yeah, so it's not like a different DSL or anything. It all
Yeah.
just makes sense. That's awesome.
So
That's
yeah,
awesome.
I also wanted to thank the Cilium community here for doing an awesome review on this PR. Like because this is the first major feature for me to contribute to Cilium, and I missed honestly I didn't think of few cases which were actually pinpointed by Sebastian. I think he reviewed the PR here for most of the code, and really I'm glad that it was able. I mean, we were able to arrive at a code which is like clean and doesn't regress any other scenarios.
And have you made you've made multiple contributions, or is this your first one? Sorry, I missed that.
So this is my first major contribution as a feature, but I made like few other contributions which like
I thought so, like bug fixes, and yeah, that's awesome. Very cool. I mean, it's always different working on a feature than like solving a bug, because then you're like introducing new code or new projects. So that's super exciting, and I'm really glad that you had a great experience with it too. That's awesome. What is some stuff that is coming in Cilium that you're excited about personally?
Yeah, so we are collaborating with the data tag as well. So we opened a CFP for making the DNS proxy highly available. So it's an FQDN filtering feature. So today, like DNS proxy is tightly coupled with Cilium agent. So if Cilium agent goes down, DNS proxy also goes down. So the pods could not resolve the DNS request. So we have actually opened a CFP with Datadog here, like to how to separate DNS proxy and target as a separate daemon set. As like today, Cilium does with Envoy. It's similar pattern, like we can run the DNS proxy as a separate daemon set and give this high availability feature for users here.
Nice. That'll be another big feature. Like, yeah, I've seen a few different implementations of something like that. So it'll be really neat to see how that comes together.
It's still in the CFPs and still in review phase. Yeah. So hopefully, like it concludes and then we can be able to contribute there as well.
Awesome. Well, thank you for joining us. I do appreciate everybody who's been here. I'm going to go in, start jumping into like what else is coming in 1.16. So feel free to hang around if you want, but I'm going to jump into the release overview, and then I'm going to wrap it for the day. So again, thank you so much for joining us. Thank you to all of you for joining us, and let's get started with this.
Thank you. Bye.
So as usual, if you would like to be aware of what's coming in a new release, you can actually join us on Slack and join the releases channel, and then you'll become more aware of like the releases that are coming in Cilium. As this is a new release, we're actually dropping the new 1.16. You can actually go to the Cilium repository, click on the release, and you're going to get a great overview of all the stuff that's coming. So we were talking about the Cilium NetKit blog that came out a little earlier. There's a refresh on BGP, which actually introduces a pretty significant change in the way that BGP is configured for Cilium. So if you're going to interact with BGP, pretty exciting stuff. There's a new feature inside of Cilium BGP, which actually allows for the announcement of cluster IP BGP advertisements for both cluster IP services and for an external IP that you have configured. Further down the stack, we also see service traffic distribution. We were talking a bit about that one. That's the contribution from Rob and a bunch of other folks working on that piece of it. Local redirect policy has been promoted to stable. Local redirect policy is where if you want traffic on a particular node to be redirected to another worker on that specific or on another pod on that specific node, local redirect policy has a way to do that. This is useful for the cases of things like node local DNS, etc. We are introducing a multicast data path. So now you can actually define multicast groups in Cilium. We are introducing a new capability of actually defining a static MAC address. Like you actually want to know what the MAC address is for an inside of a given pod, you can now specify that. Moving on down the stack, we have service mesh and ingress gateway. We talked a bit about this one. So Gateway API now introducing Gamma support, which is that east-west traffic management for cluster via Gateway API. We're using some of the same features as Gateway API. We have support for Gateway API 1.1. And this is one I'm actually pretty excited about. This is external traffic policy support for ingress and Gateway API. External traffic can now be routed to node local or cluster-wide endpoints. And that means that we can actually reduce the hops that traffic takes to get to, well, that's actually interesting, to ingress for this particular case. So if you don't have ingress enabled on all nodes, you can actually attract it only to those nodes that are actually enabling ingress, etc. So layer 7 Envoy proxy is a dedicated daemon set. We have co-hosted this with a Cilium node, with a Cilium agent for quite a long time. And in the last few releases, we've enabled the ability to separate out the Envoy daemon set and the Cilium agent daemon set. And now, from now on, we can actually make that the default, the stable default. Lots of good work in security, port range support, and network policies. We had a great friend, Nathan, talk about that. So lots of good stuff there. This is actually an interesting one. So network policy validation status. So when you define a network policy, you can describe it now, and Cilium will tell you whether that policy is valid or invalid. So taking some of the logic that we use to validate network policy when we go to do that insertion that we were talking about with Nathan, and actually being able to do that in user space so that we can tell you, hey, this network policy was invalid, which is really cool. Control Cilium network policy default deny behavior. Policies usually enable default deny for the subject of policies, but this can now be disabled on a per policy basis. Now that means, like, basically what that's breaking down is, like, if you define a network policy, by default, what ends up happening is that any traffic not matched by that policy will be dropped. And on a per policy basis, you can say, I do want to match this policy with this policy, but I don't want to affect any traffic not matched by this policy. So pretty cool. CIDR group support for egress and deny rules, adding support for matching Cilium CIDR groups and egress policy rules, loading the default network policies from file system. That was Tom Amani's work that we were just chatting about. And then support select nodes as a target for Cilium network policies, with 2 nodes or from node selectors. Traffic can be allowed or denied based on the labels of a target node in a cluster. Day 2, operations at scale. Lots of great improvements in scaling, including some of the ones that we're talking about in the 117 with the new try work that we were actually introducing there. Obviously, that's not in 116, as Nate had said, but lots of great stuff coming there. Hubble observability, cell filter support, improved HTTP metrics. There are additional metrics that can count the HTTP requests and their duration. Improved BPF measure map pressure metrics. So now we have even more visibility into the map pressure. Improvements for egress traffic path observability. Some metrics were added to this release to help troubleshoot Cilium egress routing. And KA's event generation on packet drop. That means that you're going to get a Kubernetes event when we drop packets. So Hubble now has the ability to generate a Kubernetes event for a packet drop from a pod, and it can then be verified with kubectl get events. Filtering Hubble flows by node labels. I like that feature. That's a good one. And then obviously lots of really great end user stories have come this particular release. We got some from DigitalOcean, Post Finance, Cicrid, WSO2, lots of great stuff in there. If you have not tried it out, here are the image versions available to it. And I believe that we have, so if I do Helm repo update, Cilium, show. Let's do the README. Cilium version 1.16 is out. You can see it there. So if you wanted to try doing the installation of Cilium 1.16 in your environment, you are welcome to do that. Remember that the first few releases of any software, especially with big changes like this, are going to be a little rough, but it would be really great for us if you would go ahead and try out 1.16, and if you find any issues with them, obviously you can go to the Cilium Slack and discuss your issues there. You can also open any issues that you find on the Cilium repository, which, as you know, is always right here, Cilium issues. And you can actually tag that with the version that you're opening it against, etc., etc. So definitely come and be a part of it. I'm so glad you were here, and I'm so glad to be talking about Cilium 1.16. It's super exciting. Lots of great stuff in there. So Again, thank you, everybody. Thank you to all of our contributors, not just the four that were here with us today, but everybody who's been a part of this release. And thank you for all of the work that you do, whether direct or indirect, as it relates to the Cilium OSS project. And now I will turn you loose on this beautiful Friday afternoon. I hope that you have the greatest weekend of your life. And I will say thank you, and I'll see you next time.